So let's start today's tutorial. So I'm gonna solve the assignment which had been given previous year. So let's see the first question. So question number one. Here let x1 x2 action be independent identically distributed random variables with expectation of exi is mu and variation it's the expectation of xi square is less than infinity for I equal to 1 to n. Now consider an estimator t of x is 2 by n plus 1 I xi. For the parameter mu. And now we have to check that this estimator is unbiased and consistent or not. We have to check. So let's see. So we know that to check its unbiasedness we have to first check the expectation of tx. So if the expectation of tx become equal to theta, then we can say that this tx is an unbiased estimator. So let's check that expectation of tx will be 2 by n plus 1 summation of expectation of I xi, where I equal to 1 to n. Now 2 by n plus 1, and simply this will become I1 to n. I expectation of xi for every I is mu, so I simply write it mu. Now this means 2 mu by n plus 1 and summation of I equal to 1 to n I, and this summation is nothing but summation of the natural number from 1 to n, that is simply n into n plus 1 by 2. So this is cancel out, this becomes n. So that means T is a unbiased estimator. Now let's check that it is consistent or not. To check its consistency, we have to show that the variance of Tx goes to 0 as n tends to infinity. So we have to check the variance of Tx. So this will become 4 by n plus 1 n its square and summation of I square and variance of xi. Now the variance of xi, variance of xi is, we know that the expectation of xi square not is a finite number, then the variance of xi will be also a finite number, and we can take variance of xi. Since the variance of xi is same for all i's, we can write it simply for variance of xi n square n plus 1 its square to summation of I square, and the sum of the natural number is 4 by natural number square is 4 by n square n plus 1 square variance of xi, and this is n into n plus 1 into 2n plus 1 by 6. So this will be variance of xi 4 by 6 2n plus 1 by n plus 1 into 1 by n. Now we can write it 4 by 6 variance of xi. This will be 2 plus 1 by n and 1 plus 1 by n and 1 by n. So if n tends to infinity, this tends to 0. So that means this estimator for mu is an unbiased and consistent estimator. So that's all. Now let's move towards the next question. Question number 2. Question number 2. Let x1 x2 xn be random samples from a uniform distribution between 0 to theta. And suppose T1 and T2 be the method of moment estimator and maximum likelihood estimator of theta respectively, then which one of them or which one of the following is true. So the options are A, T1 and T2 are both consistent, B, T1 and T2 are both unbiased estimator, for theta. See, T1 is consistent but T2 is unbiased, and D, T2 is consistent but T1 is biased for theta. So basically we have to check the unbiasedness condition and consistent condition, that T1 and T2 whether they are unbiased and consistent or not. So we're gonna check that. Okay, so first of all, T1 and T2. Okay, T1, we get the T1 from the method of moment estimator and T2 from maximum likelihood. Let's check that. So first of all, method of moment estimator. So in this method we know that 2x bar is equal to theta. So that means that if I sum over the all variable, that means then we'll actually okay, sorry, let me. So suppose x1, x2 dot dot xn, these are identically distributed random number follows a uniform distribution between 0 to theta. Then the T1 is, we have to determine only one parameter, so we have to calculate only one moment, and that is the first moment, that means mu1 prime, which is summation 1 over n sum over sum over xi, so sum over xi I equal to 1 to n, and we know that the expectation of these is equal, that we know that these will be, if n tends to infinity, this is actually theta by 2 is T1 or T1. So that means our estimator for theta, this is first moment mu1 prime, we know that mu1 prime is theta by 2, so theta will be mu1 prime, 2 mu1 prime, so our estimator will be 2x bar, that's it, 2x bar. And to check its unbiasedness, we have to check the expectation of T1, so 2 expectation of x bar, so that will be same, because expectation of x bar will be theta by 2, so 2 into theta by 2, that will again theta, so that means the expectation of T1 is theta. And to check the consistent property, let's check the variance of T1 will be 4 by n variance of any variance of any variables, since they are identical random variable, the variance of every one's a same. So this is basically variance of t1 means 4 by n variance of, okay, let me 4 into variance of x bar, and the variance of x bar means we know for the uniform distribution it is nothing but variance of single variable by n, and the variance of single variable is, if we calculate, the variance of single variable is nothing but theta cube by 3, so 4 by n, so 4 by n, this is theta square by 3. So it is, let me check it whether I'm right or wrong. Yeah, so variance will be, let me calculate the variance. So x square into 1 by theta dx 0 to theta, so this will be 1/3 x cube by theta 0 to theta, so this will be theta square by 3, and then this will be 4 by 3 into 1 by n theta square. So as n tends to infinity, the variance of t1 tends to 0. So that means that t1 is both consistent and unbiased. Now let's check the the same condition for the t2. So t2, we go, t2 is the estimator that has been derived from maximum likelihood estimator. Maximum likelihood estimator. So to do maximum likelihood estimator, we have to know the likelihood function, that is the joint distribution. So this is x bar theta, and the joint distribution is simply 1 by theta n when 0 xi less than theta otherwise. Now from the maximum likelihood estimator, we know that we have to choose a value of theta for which this function will be maximized. That means we have to choose the minimum possible value of theta. And what will be its minimum value? Now one condition all the random variables should follow is that all variables should be less than theta. That means at least the theta can be equal to the nth maximum, that is the maximum, or this is maximum among these numbers. So that will be the minimum value of theta. So then t2 is nothing but the nth maximum between the observation of this n in our sample. Now what will be the distribution, what will be the probability that these t2 or simply xn, that is xn, is less than equal to small x? If it is less than equal to small x, then all the variables should be less than equal to small x. That means this is equivalent to say that all the variable that x1 less than small x equal to x2 less than small x or xn less than small x. That means since these alls are IID variable, all are independent, then we can write it as multiplication, and any single, what is the probability that x1 less than x by theta, that is nothing but x by theta to the power n. So this is the cumulative distribution. Then from here we can get the probability distribution function of xn, which will be nothing but x by theta to the power n, x to the power n minus 1. Now let's see the expectation value of this action. Expectation value of this t2 or xn, that will be nothing but 0 to theta, 0 to theta, and 0 to theta, 0 to theta x into n x to the power n minus 1 theta to the power n dx. Now the range, actually this is valid for the value of x, where x in between, here the x should be between 0 to theta, so that's all. And this is n by theta to the power n, 0 to theta x to the power n dx. So this will be n by n plus 1 theta to the power n plus 1 by theta to the power n, so that is n by n plus 1 theta. So you see that expectation of this estimator is not equal to the actual parameter. That means this is that t2, this means t2 is not unbiased estimator. Now let's check its variance to see whether it is a consistent estimator or not. So to check it, so expectation of x square minus expectation of x its square, so that is 0 to theta x square n, this is n by theta to the power n x to the power n minus 1 dx minus n square by n plus 1 x square theta square. So this is 0 to theta n by theta to the power n x to the power n plus 1 dx minus n square by n plus 1 theta square n by n plus 2 into theta to the power n plus 2 by theta to the power n minus n square by n plus 1 square theta square. So this is 1 by 1 plus 2 by n into theta square minus 1 by 1 plus 1 by n square theta square. So you see 1 by 1 plus 2 by n minus 1 by 1 plus 1 by n square theta to the power n. So as n tends to infinity, this will become 0. So that means T2 is not an unbiased, but it is a consistent estimator. So that's it. Now this is the question number 2. Now let's move, let's see the question number 3. question number 3. Wait a minute. Let's see question number 3. A random sample x1, x2, xn of size n is taken from the log normal probability distribution function, which is given below like that. Fx mu sigma is nothing but 1 by root pi x sigma e to the power minus 1 by 2 sigma square log x minus mu square, where x greater than 0 and mu belongs to real number sigma greater than 0. That's all. Now from the method of moment estimator, we have to find the parameter sigma, mu and sigma square. So let's do it. So there are two parameters, so we have to know the two moments. One is mu 1 prime. For log normal, we know that the first moment is nothing but e to the power mu plus sigma square by 2, and the second moment mu 2 prime is e to the power sigma square minus 1 into e to the power 2 mu plus sigma square. Now we know, suppose from the moment of method of moment estimator, we know that we have to calculate mu and sigma square by sample mean and in terms of sample mean and sample variance. Suppose the sample means is x bar and sample variance is s square, then this is x bar is e to the power mu plus sigma square by 2, and s square is e to the power sigma square minus 1 to the power 2 mu plus sigma square. So if I do the thing, then if I do this x square by s square, or I do this s square by x bar square is equal to e to the power sigma square minus 1. From here we'll get e to the power sigma square equal to 1 plus s square by x bar square. So sigma square is log of 1 plus s square by x square. So this is the method of moment estimator for sigma square. Now if I put this value here, so let's put it. So log of x bar will be mu plus sigma square by 2, and mu will be log of x bar minus half of log of 1 plus s square by x bar square. So that means these will be okay. So that will be the, or if I simplify it, I can simplify it like that: log of x bar minus half log of x bar square plus s square plus half log of x bar square. So this will be nothing but 2 log x bar minus log of x square plus s square half. So that will be the moment estimator that will be the estimator for mu, and that it will be the estimator for sigma square. So that's it. Now let's move toward the question number 4. Here let x1 x2 xn be a random sample of size n drawn from binomial MP where M is known and P belongs to 0,0.5 distribution. Find the maximum likelihood estimated of expectation of x1. So we have to find the maximum likelihood of the expectation of x1 and m is known. So this is simple. So first let us see what is the expectation of x1. So since it is a sample collected from binomial of sample size n, so this will be nothing but m into p. We see m into p. Now we have to write the maximum likelihood function. So we have to write the maximum likelihood function. The likelihood function will be the joint distribution, that will be p, and since m is known, we have to only know the parameter p. We have to only estimate the parameter p. So this is nothing but I equal to 1 to n m c x I p to the power x I 1 minus p to the power m minus xi. Now its log likelihood will be ln L of px, so that is summation, so that is summation of I equal to 1 to n I equal to, let me simplify this, ip equal to I equal to n mc xi, and other thing can be taken as summation of xi 1 minus p summation of m minus xi. So this will be 1 to n mc xi p n x bar and 1 minus p mn minus n x bar. So this will be ln mc xi plus n x bar ln p plus m minus x bar into n ln 1 minus p. Now the differentiating with this equation with respect to p will get TL TP. To get the maximum likelihood, we have to maximize this function. So for that we have to take such value p for which TL TP is 0. So let's calculate the value of p. DL dp will be n x bar by p minus m minus x bar into n pi 1 minus p is 0. So if n not equal to 0, then we can write it x bar 1 minus p equal to m minus x bar into p. So this will give x bar equal to mp, and we want to calculate only that thing, expectation of x1, that will be mp. Now another thing is, let me write it. So p will be x bar by m. Now another thing is that we know that the probability belongs to 0 to 0.5. Now this is that, and you will see that del L del P greater than 0. So from here you can del L del P is, that means n p1 minus p x bar 1 minus p minus m minus n minus x bar into p greater than 0 1. So this is cancel out. So this is x bar minus mp greater than 0. So this is positive. So when x bar greater than mp, or when p less than x bar by p, then it is a monotonically increasing function, then it will decrease. So that means the graph will look like is if this is a likelihood function, this is p, this will be at from somewhere for p equal to 0 it has some value something like that, and from there it will go increasing, and from here you will see, you can easily see that it will decrease when x bar less than mp, that means when p greater than x bar by m. So that means this is somewhere where will be p, this is x bar by m. Now you see we have to get we have to choose such values of p which is also remain in this region. Now if this value 0.5 is larger than x by m, that means if x bar by m is less than 0.5, the x bar by m is allowed. But if p is 0.5 is in this side, that means if 0.5 is less than x bar by m, then this probability we cannot take the p value here, so the maximum value for which the likelihood will be maximized, that will be exactly at 0.5. So that means the estimator of p, the estimator of p is x bar by m if x bar by m is less than 0.5, less than half, and it is half if x bar by m greater than equal to 1. So that means the estimator by method of likelihood estimator, it is minimum between x bar by m and half. That's it. So that means the estimator of expectation of x1, that means mp, will be the estimator of mp will be minimum of x bar and m by 2. So that's it. Now let's move toward the question number 5. So here the question is, let x1, x2, xn a random sample from continuous distribution with probability density. I mean, this is the IID random variable with probability density is e to the power minus x minus theta, where x greater than theta. Now consider the class estimator. Consider the class estimator. Consider the class estimators t x1 xn, that is estimation for the x1, the minimum value, that is minimum value among the x1, x2, xn. Now find the smallest estimator of b. Find the estimator has the smallest mean squared error, that is MSE class, MSE. Okay, so we know that the x is, all x is greater than theta, so the probability of x small 1, the cumulative probability being x is, that means the probability of x1 should be less than equal to x, that means 1 minus of probability x1 greater than equal to x. So if x1 greater than x, that means all the random variables has to be greater than x because it is a minimum. So that means 1 probability that x1 greater than equal to x, x2 greater than equal to x, dot dot xn greater than equal to x. And since all are IID random variable, that means this is 1 minus, this is theta 2, since all variables goes from theta to infinity, so theta so not theta, so x to infinity, so this is x to infinity, x to infinity, e to the power minus x minus theta to the power n. So these will be 1 minus e to the power minus n x minus theta. And what will be the PDF? PDF will be derivative with respect to x, f of x1x, so that is n e to the power minus n x minus theta, where x greater than theta. Let's check the expectation of now why I am doing this, because I want to calculate the square of this random variable. So to do so I have to expectation of the square, so that's why I am calculating its PDF, and now I am calculating its mean, that expectation of ex1, that variable will be, so this is theta to infinity xn e to the power minus n x minus theta d theta. So this will be, let's do it by parts. So this is n theta, first term will be x e to the power minus n x by minus n theta to infinity, this will be plus 1 over n, first derivative of x, this will remain, this will become 1, and e to the power minus x minus theta dx, this is theta to infinity. So n e to the power n theta, this is minus x by n e to the power, this simply right, this is simply, at infinity this will be 0, at theta it will become plus theta by n e to the power minus n theta, this will become 1 by n square, this will again become e to the power, this is there is no, this is not there, so this will become e to the power minus n theta. Now this will theta plus 1 by n. Now calculate the expectation of x1 its square, so this will be integration theta to infinity x square n e to the power minus n theta minus x minus theta dx, so that will be e to the power n theta, first term will be x square minus by n e to the power minus nx theta to infinity. Then it will become first derivative of this, that means 2 integration, it will become plus pi n integration theta to infinity x e to the power minus nx dx. And we know that the integration x e to the power minus nx, that is x e to the power minus, that will be this inside term theta by n e to the power minus n theta, that is, let's put it simply that, and that is the, if I put infinity it will become 0. So if I put theta it will become theta square by n e to the power minus n theta plus 2 by n, that is, I have already done this integration, that will be theta by n e to the power minus n theta, theta by n e to the power minus n theta, and this is plus 1 by, this is 1 by n square e to the power minus n theta by n square e to the power minus n theta. So if I put all the term all together, we'll get 2 n e to the power n theta, this is theta square by n e to the power minus n theta plus 2 theta by n square e to the power minus n theta plus 2 by n cube e to the power minus n theta. So this is theta square plus 2 theta by n plus 2 by n, 2 by n square. So this is that. Now let's calculate the mean square error in t, that is expectation of x1 plus p minus theta square. So I want to calculate, we want to estimate theta. So to estimate theta we use the statistic x1 plus p, or this function. So now calculate the mean square error, that means this minus actual value of theta, this is the estimation and this is the actual value. Now this will be x1, expectation of x1 square plus 2 expectation of x1 into p minus theta, another thing is plus p minus theta its square, and expectation of all the things we know, that this means theta square plus 2 theta by n plus 2 by n square, this is 2 n2 theta plus 1 by n into p minus theta, this is p minus theta square. So if we simply take 1 by n square, it will become theta plus 1 by n its square plus 2 into theta plus 1 by n to p minus theta plus p minus theta square. So this will be 1 by n square plus b minus theta plus 1 by n its square. So this is 1 by n square plus p plus 1 by n square. Now say this is g is a function of p. Now for the smallest mean square error, we have to find such values of b where this is smallest, that means g prime b will be 0, that means 2b plus 1 by n will be 0, that means b will be minus 1 by n. This will be extremum point. Let's see it's whether it's minimum or maximum. So let's g double prime b, so that will be 2 and it is greater than 0, that means at point b at point minus 1 by n, it is maximum, it's minimum. So that means b at b equal to minus 1 by n, the mean square error is minimum. That means x1 minus 1 by n is in the MEC smallest mean square error class. So that's it, smallest. So that's the question number 5. Now let's move toward the question number 6. Question number 6. Wait a minute. Question number 6. Question number 6 is x1 x2 dot xn be a sample from u theta minus 10 to theta plus 10, where theta belongs to 0 to infinity anywhere, and x1 is the minimum among x1, x2, xn. Xn is maximum among x1, x2, xn. Then we have to find the minimum likelihood estimator of theta. Excuse me. Or we have to check which of the following statement is true. A, that x1 plus xn by 2 is unique MLE of theta p2 by x1 plus xn is a MLE of 1 by theta. C, x1 plus 12 is an MLE of theta. D, xn minus 12 is an MLE of theta. So that's we will check. So let's see, this is a uniform random variable. That means if we write the least square function, least square function will be fx will be 1 by 20, because 1 by this theta plus 10 minus theta minus 10, so that will be 20 if theta minus 10 is less than x and is less than theta plus x is less than from theta plus 10 and 0 otherwise. That's it. Now from here we have to calculate the theta, estimate theta. Now there is no way here to calculate by differentiate it. Now to calculate it we have to use other methods. So first, if you see that joint probability distribution, that means the L, that likelihood function, that is x theta, that is not dependent on theta, that will be 20 to the power n if 20 to the power n if all n, all xi is belongs to all xi, if all xi belongs to this minus theta less than xi less than theta plus 10 for all I belongs to 1 to n, otherwise 0. Now see, this likelihood function does not depend on theta, but from here, this from the region of this function, we can get an idea what the value of theta will be. So first check the two limits, possible limits of xi values. So possible limits are, so one is theta minus, for all x, theta minus 10 will be less than xi. So that means this condition has to be satisfied, right? Whatever, since I know the sample value, I know all the sample random sample, that means we know x1, x2, x3, xn, and another thing, we don't know the theta, and we know that theta minus 10 should be less than this, that this means for all I, that means theta minus 10 should also less than the smallest number or smallest observed sample in the observed sample, x1, x2, xn. So that means theta has to be less than from x1 plus 10. That the thing we can only say. And other thing is theta plus 10 is greater than xi for all I. So theta should be greater than xn minus 10. So that the two thing we can say. That means theta is a number which belongs between xn minus 10 xn 10 to x1 plus 10. So any number between these two limit is an estimator. Any number is an estimator for the theta, any number between these. So that means first option is not correct. There is not an unique estimator, is not there. And 2 by, let's check it. So is this function, that means x1 plus x2 by 2, that is equal to x1 plus 10 plus xn minus 10 by 2. This number obviously a number between this range. So that means this is a estimator for theta. And since the function g theta is 1 by theta, is an 1-to-1 function of theta, that means 1 by x1 x2 by 2 by 2 should be also, that means 2 by x1 plus xn. This is also a estimator for 1 by theta. So that means the option B is correct. Option B is correct. That means option B is correct. Now option C, x1 plus 12. Obviously the theta has to be less than x1 plus 10, but x1 plus 12 is is outer the range, because x1 plus 12 is greater than x1 plus 10, but the estimator of the theta should be lesser than this number. That means x1 plus 12 cannot be a MLE. and D also similarly xn minus 12 is less than xn minus 12 is less than xn minus 10, but for to be an estimator of theta it has to be greater than that, greater than from this number xn minus 10. So this means xn minus 12 cannot be an estimator, so this is also not true. So that's all. That's the question number 6. Let's see question number 7. Question 7. So there are n random variable independently. They are drawn from a normal distribution. These now we have to check, define a W estimated 1 by 2n square summation of j equal to 1 to n xi minus x its square. Then estimated, yeah, we have to check these whether this estimator for sigma square is an estimator which is unbiased or consistent not. So let's check that. So first of all we check the expectation of W, that is 1 by 2n square. There will be another sum, that is I. So summation of I, summation of j. So let me write it in this way: x bar minus xa minus x bar square will get 1 by 2n square, summation of I, summation of j, xi minus x bar its square, plus summation of I, summation of j, xa minus x bar square minus 2 summation of I, summation of j, xi minus x bar into xa minus x bar. So this will be 0 because summation of I, xi minus x bar, these two are independent, so you can write it in this fashion: summation of I, xi minus x bar, summation of j, xa minus x bar, and these will be cancelled out because summation of xi, this will become summation of xi means x n x bar, and this is n x bar, so this will be cancelled out. So that means this term is not there. So 1 by 2n square, only two term is there. One is summation of I, and here you will see there is a no j dependence, so this will simply n xi minus x bar square and plus summation of j simply n. This is also similar, xa minus x bar its square. So this is basically 2n, and these are same. If I change the symbol, these two are same, so that means this is nothing but we can write 2 into summation of I, xi minus x bar square. This is a method of symbol. If I change j to y, then it will become identical. This is actually okay. Oh, I missed a factor, that is expectation. So let me write it expectation. So stay in call. Yeah. So expectation, there is a expectation of all the thing, expectation. So that means expectation of these. But we know that the expectation, so n minus 1, if we take n minus 1, expectation of 1 by n minus 1 summation of I, xi minus x by square, we know this expectation is sigma square. So this is because this follows a chi-square n minus 1 distribution and the mean is n minus 1. So that means this is that. So this is not an unbiased estimator for sigma square. Now let's check the whether or not it is an consistent estimator or not. So let's check that. So to check the consistent estimator, so as n tends to infinity, if it's so if n tends to infinity, expectation of w, that means limit n tends to infinity n minus 1 by n sigma square, that is actually 1 minus 1 by n sigma square limit n tends to infinity. So this is sigma square. So that means at n tends to infinity, so w is a w become, so expectation limit n tends to infinity, expectation of w becomes sigma square. That means it is a consistent estimator. So w is not a unbiased estimator, but it is a consistent estimator. So that's all. Now let's toward the question number 8. Okay, so here observe value, random values are 0 and 1. That means x1 equal to 0, x2 equal to 1, and from IID random variable, that is n theta theta, the maximum likelihood estimate of theta. So we have to maximum likelihood estimate of theta is. So let's check that. So first of all, let's write the likelihood function, that will be 1 by root over 2 pi theta e to the power minus theta by 2 x minus theta, x1 minus theta into 1 by root over 2 pi theta e to the power minus theta by 2 its square. So not theta by 2, 1 by 2 theta, 1 by 2 theta by 2 theta x2 minus theta square. So it is simply 1 by 2 pi theta e to the power minus 1 by 2 theta x1 minus theta its square plus x2 minus theta square. So log likelihood function will be minus log 2 pi minus ln theta minus 1 by 2 theta x1 minus theta its square plus x2 minus theta its square. Now to calculate the value of theta, we have to find the where TLT theta is 0. So that is minus 1 by theta minus plus 1 by 2 theta square x1 minus theta its square plus x2 minus theta its square minus 1 by 2 theta minus 2 x1 minus theta minus 2 x2 minus theta is 0. So that is 1 by 2 theta square plus 1 by So if I multiply both the side by 2 theta square, we'll get here here minus 2 theta plus x1 minus theta square, x2 minus theta square. Here we'll get plus 2 theta x1 minus theta plus 2 theta x2 minus theta equal to 0. So that means x1 square plus theta square minus 2 x1 theta plus x2 square minus 2 x2 theta plus theta square plus 2 theta x1 minus 2 theta square plus 2 theta x2 minus 2 theta 2 square minus 2 theta equal to 0. So this is cancelled, this is cancelled, so we can cancel this with this. Now we can write it minus 2 theta square minus 2 theta, right, plus x1 square plus x2 square equal to 0, or theta square plus theta minus half x1 square plus x2 square equal to 0. Now theta will be minus 1. Theta can be, theta's values can be plus minus root over b square minus 4ac, so 4 into half x1 square plus x2 square by 2. But you see the theta cannot be, theta's value cannot be negative, so that means theta has to be theta equal to minus 1 plus root over of b square minus 4ac. This will be plus 1 plus 2 to x1 square plus x2 square by 2. Theta has to be greater than 0 because sigma square is theta. Variance cannot be negative. So that is square. Now put the value of x1 and x2. x1 is 1 and x2 is 0. So we put that minus 1 plus root over of 1 plus 2 by 2. So that means minus 1 plus root 3 by 2. So that is the answer. That is the maximum likelihood. If I observe random variable 0 to 1 from a normally distributed random variable with mean and variance is theta. Now let's go towards the question number 9. Question number 9. Question 9 is, suppose that this is the thing, that y I equal to alpha plus beta xi plus epsilon I, then we want to fit linear model. Then what are the least square estimate? Least square estimate. So suppose that this is beta 0, this is beta 1 xi plus epsilon I. Now what are the estimate for beta the least square estimate of beta 0 and beta 1? Okay, let's do it. Let's do it. So we have to, the errors are epsilon I square, we have to sum it up, so that is nothing but yi minus beta 1 xi minus beta 0 h square sum over I. Okay. Now to estimate beta 0 and beta 1 value, we have to first derivative. And suppose this quantity is s, tail is suppose this is alpha, let me write it, this is alpha and this is beta. Tail is tail alpha is minus 2 summation of I, this is yi minus alpha minus beta xi equal to 0. So this will become y bar equal to alpha plus beta x bar. Similarly, when you do tail s till beta, that will be minus 2 summation of yi minus alpha minus beta xi into xi equal to 0. So that is summation of xi yi minus minus alpha x bar minus in alpha x bar minus in alpha x bar, this is minus n let me write it properly. Summation of I xi square is 0. So from here we will get so write it this way. Okay. So this is that. Yeah, the beta I'm missing, this beta is there. That's it. So this is, if I this is nothing but n xy or yxn, or so right, n yx or xy, xyx, this is minus n alpha x bar, this is ss, n ss equal to 0, or is yx minus x bar alpha minus s x x beta equal to 0. So from, if we solve these two equation, you will get that beta equal to is yx by is xx, so and alpha equal to y bar minus beta x bar, beta cap x bar, and this is beta cap, this is alpha cap. So that's it. And another thing is these are unbiased estimators. That means if the expectation of beta is expectation of s yx by s xx, that is 1 by s xx, expectation of s yx, and s yx is is yx is, so I have done it wrong here. So this is equal to summation of xi minus 1 by n summation of xi yy minus x bar y bar equal to syx. So there is a multiplication x bar y bar plus, so syx x I equal to 1 to n xi yi minus n x bar y bar. Now expectation of syx xi expectation of yi plus n expectation of y bar xi expectation of, so this will be alpha plus beta xi is expectation minus n x bar alpha plus beta x bar. So this is alpha x bar okay. So I did it wrong. Okay, let me write it properly. So expectation of xi yi minus n expectation of s expectation of y bar. So this is expectation of summation of xi alpha plus beta xi minus n x bar. This will be alpha plus beta x bar. This is summation of alpha x bar plus beta expectation of xi square square I think there is no need of take this expectation, so get rid of this. I have to take the expectation. Okay, let keep the expectation. So expectation that is that expectation of x square minus beta n x bar square minus alpha, this is expectation of base alpha n x bar, so this is cancel out, and this is beta expectation of this is nothing but xx. So estimated, that is expectation of beta cap is actually beta, so this is showing that this is an unbiased estimator. And similarly one can show that alpha is also an unbiased estimator. Let me read that. Alpha cap is y minus beta x bar, so expectation of this means expectation of this, so expectation of y bar beta cap, expectation of this will be expectation of s, this is y bar is alpha plus beta cap x bar minus beta cap x bar, so this is nothing but alpha plus beta cap x bar minus beta cap x bar. So this is alpha. So this is also unbiased estimator. And another thing is that the means error sum of these squares, that means these I equal to 1 to n yi minus alpha plus alpha minus beta xi alpha cap beta xi cap square, these will be syy minus syx square by sxx. And the if I say this is SAC, that sum of square of the error, then the expectation of this, the sum of the square of the error by n minus 2 will an unbiased estimator for the sigma square. So that's it. That's the question number 9. Now let's conclude the question number 10. That is question 10. Question number 10 is, so it's a table one, two, three, four. That is enough. xi yi I equal to 1 2 3 4, xi is minus 5 1 2 2 1 3 3 5. Now we have to write an equation for y and x. So we know that y equal to alpha plus beta x, where beta is can be estimated by syx by sxx, and alpha is y mean minus beta x beta cap x mean. Now let's calculate the beta. So first calculate syx. Syx will be 1 by n summation of xi yi minus x bar y bar, and x bar y bar means summation of x, so let it write x bar here and then write y bar. Okay, here let's write here average bars. So average is 2 plus 2 4 plus 1 5 minus 5, that is 0, and here 3 3 6 plus 7 12. Okay, now right here the x into y, so that will be minus 5, this is 3, this is 6, this is 10, this is okay. Now sum of this whole thing will be sum and 1 by okay 1 by n, this is actually 1 by n, that will be 3, right? 5 plus 6 is 12, by 4 is 3, so again this will be minus 5 plus 3 8 plus 6 8 plus 6 14, so 14 by 4, so that will be 7 by 2. 16 plus 19 14 by 4, so 7 by 2, so this is actually 7 by 2 minus this is 0, so 0, so this is 3.5, beta is 3.5. Let what is the alpha? Alpha is y bar is 3 minus beta is 3.5 into x bar, that is actually 0. Alpha means 3. Correct. Yeah, one thing I have missed is yx. Oh, sorry. This is not, this is 7 by 2, right? And I have to find the sxx. Sxx means sxx means, sorry, sxx, I have to find also sxx. sxx, I also find the xxx, that is 1 by n sum of xi minus x bar x square, and we know that x bar means 0, that means 1 by n xi square. So xi square, let's draw another thing, right? Xi square mean, so x square 25, it is 1, it is 4, it is 4. So this will be 26 plus 8, 34. This is 34 by 4. 34 by 4 means 17 by 2. So beta cap will be syx by sxx. So 7 by 2 by 17 by 2, so that will be 7 by 17. Okay, and alpha is y bar minus beta cap into x bar. Since x bar is 0, this is 0, y bar is 3. So that means our equation will be y equal to 3 plus 17, 7 by 17x. So that's it. So that's the question number 10. That was the last question for this 2-day session. So now today I will leave this meeting here. That's all.